I'm going to show you how to download satellite data from a NASA API using a free API key. Shout out to NASA. Now, NASA uses satellites to collect data about wildfires. They made this data available to the public back in 2021, and I'm going to show you how to get your hands on this data for free. And to do this, we're going to use a Python script, and this script will create an Excel file. It will also create a PowerPoint presentation, and it will create a text file, and it will also create a graph based on the data that we've downloaded. And so now I'm going to show you the code for this Python script from A to Z, coming right up. Stay tuned. Jump right into the code. So I've got a little comment at the top of my Python script here. This explains what the Python script does. So if I put this away and come back to it in 6 months, I'm going to know what it actually does. I don't have to read through the code to get the gist. So basically, we're going to need a free API key from this website. Let me open this up. All right, here we go. So first thing we need to do to download some NASA wildfire data from their satellite imaging system. So you got to go to this website. I'll put the link in the description. It's the Fire Information for Resource Management System. And so you're going to click on Get Map Key. And you need an email address, something you can receive email at. They're going to send you a key. And then all you do is just create a file. I've got one right here. It's called map key. I'm not going to show it because it's got my map key in it. There's other ways to store your map key as well, so you can reference it in your program without hard coding it into your script, which is, you don't want to hard code into your script in case you have to share your script at some point and then you're going to give away your API key. But anyhow, let's move on. All right. So that's basically beginning. So I already got the map key. And there's some other stuff, just some basic info. Let's jump into the code here. Now I've got the requirements installed already, but if not, I have this requirements.txt right here. So we're going to be using requests, panda, matplotlib, XLSX writer, numpy. I tried using geopy. I don't think I ended up using it. That was to transfer the coordinates into translate the coordinates into actual locations. You'll see what I'm talking about later. And then I also got OpenPyXL. That's to open an Excel file. All right, so back to our code. As you can see at the top, we got a bunch of imports. And so that's the first thing you do in Python. You import all the libraries you're going to be using. So we're using a bunch of stuff. It's going to be doing some math. It's going to be plotting some stuff on a graph. So that's why we have all this matplotlib, numpy, pandas. That's all math-related libraries. And you can see it's going to give me a little description of it here. This is my code editor giving me a little description of NumPy. All right, moving on from that. So there we go, Firms Area API. That's the website that we're accessing. And then there's a few different options for satellites. These are the names of the different satellites. We're using this VIIRS and some other stuff here. Now maybe we should be using the Landsat NRT. Looks like it's US California only. Now I'm going to try changing this real quick, see what we get. Let's do that for this video. All right, I'm going to change that default source. These are the sources you can use right here. Let's hopefully, if it doesn't work when we run it, we'll come back to this and we'll change it back. But all right, so first thing it does, it builds a URL. And so that's what this function does right here, as you can see. And then we got some arguments for passing to our function, map key, source, area, days, date. And that's all the data it's going to collect from the URL, or the API, I should say. And then it's going to return that, and it's going to write it to a file. That's what this F is. And then, or that's what a base equals F, quotes, all that. And then we got a map key loader. That's going to load our map key from our map key file over here. And so that way I could show you the script without showing you my API key. And so that way you can, you got to use your own API key if you want to access this. But it's free to do it, and it's free to access, free to get the API key, so don't worry about it. You can even just create a burner email and just get your API key, and then just never use that email again. That always works. All right, moving on. Got our def fetch fires function. All right, so it's going to create a CSV file. We're passing some arguments: map key, source, bbox. So that's the coordinates that we're specifying. So that's our latitude and longitude. So that'll come up later. I won't explain that too much right now. Then we got our days and date. So we request from 1 to 10 days from the API. And so less data, or if you only request 1 day, obviously you're going to get less data. If you request 10 days worth of data, you're going to get a lot of data. So we're building URL. So that's going to create our URL and pass our arguments to the URL, to the API. And then we're creating a request, a GET request right here. And so that's all pretty straightforward. And then there's just some exceptions. So if there's any errors, it should handle the errors. All right. Now we got normalized times. So that does something. Choose intensity column. I'm not going to worry about that right now. All right, so function save to Excel. So this is our function that actually saves the data to Excel. And as you can see, we got some arguments right here. And we could change these if you like. This is going to be a tab delimiter right here, this line right here. That tells you whether you use a tab or a comma or a pipe symbol to separate your data. However you want to do it. I use a tab. That's what \T is for. So, but I mean, you can Google that, or ask your local AI or whatever to explain different separations of for your data in a CSV file. I assume if you're watching this, you know how to separate data in a CSV file, and you know what a delimiter is. Looks like it's got an explanation right here. Delimiter. Yeah, it's got explanations for the different arguments. So that's nice. Okay. So as I'm explaining it, it's actually in the code if you want to read that. I'll put all this on GitHub, put a link in the description, so you can look through it at your own pace. Or if you just want to pause the video and peruse the code, you can do that as well. I'll wait for you if you pause the video. All right. Now, okay, so this is where we get to the map, or the graph. It's going to plot a graph, not necessarily a map. I mean, it's kind of a map, I guess, but it's a graph map. Whatever, it's a map. All right, it's the map. I'm the map. All right. So pretty straightforward. It creates a map based on the data from the Excel file, and based on the data frame data, right? Yep. So you're passing in data frame, so that gives you all the data. It turns into a PNG, gives it a title. Pretty straightforward. And we've got a little description right here of what it does, the function. All right, so I'm going to move on from that. I'm going to scroll down. As you can see from the side over here, it's pretty long. There's about 400 lines of code right here. So, all right, so this is summarize. I'm not sure what that does. I'm going to skip that. All right, make PowerPoint. Here we go. So this is actually what makes the PowerPoint. So if you don't want to make a PowerPoint, you can probably comment out this function or just delete this function if you want to use this code in the future. But this is what creates a PowerPoint, and this uses Python library. So you may not know, but you can create Excel files and PowerPoint files and text files with PowerPoint, or I mean with Python. So, all right, here we go. So down here in our main function, we're actually creating an argument parser, and we're going to pass some arguments directly to our CLI. So when we access the API, it needs some extra information, and this is where you can set that information so it automatically puts it in. So when we run the Python file from the terminal, we don't have to actually add all these extra arguments in our CLI. We don't have to add all these extra commands to the command line, or the you have to prepend these commands. I mean, that's the word for it. All right. You probably know what I'm saying. Anyhow, so ap.add argument, that's pretty straightforward. It's adding a map key file. It's specifying our map key file. It's specifying a source, specifying the bounding box, specifying the amount of days. We have default as 3. So if you want more days, you just change this default right here. And that will change it everywhere that the arg is used. That's one of the benefits of using arguments right here. We only have one spot where we need to change it. As you can see right here, we can actually use these args now. So I can say args.mapKey, and then it's going to come up here. It's going to say, okay, ap.addArgument mapKey. And it's going to find whatever I specified. It's a run right here. And so yeah, that's why we use the map key, the args, and all that. All right. And this is just basically calling all the functions that we created. So we're going to load our map key. We're going to create a region label. Then we're going to save it to Excel. We're going to create a graph, or a map in this case. Since it's coordinates from the entire world, it's going to kind of generate sort of a graph/map. And then it's going to also make a PowerPoint after that based on the data. And then it's going to add our PNG in there. And it's going to add some other data for us. You can specify what kind of data you want to add. So if you're making reports every day with the same kind of data, and for some reason you need to make an Excel and a PowerPoint, you could actually use this kind of type of a script to actually generate all that all at the same time. Especially if you're pulling the data from the same source every day. All you got to do is specify your range, and it'll organize all your data however you like it, and it'll do it the same every time. So without further ado, I'm going to pull up the terminal here. Let's run this script, wildfire report.py. All right. Now it shouldn't take too long to generate the Excel file, the PowerPoint, the text file, and it's also going to generate a graph. So it's going to generate 4 different items from one script. And it's all based on the same data as well. So what we're doing right now, we're pulling some data from the internet. We're creating an Excel file. We're also generating a PowerPoint presentation, generating a text file, and we're generating a graph. And this will show all the wildfire detections and around the globe. This is based on NASA wildfire satellite data. All right, so there we go. As you can see from our terminal, it is done. And as you can see over here, we got some extra files here. We got firemap.png. Let's open it up. I drop the terminal down. Boom. And as you can see, we got our graph right here. Wildfire detections in the world. And this is the satellite it used. 197,238 unique locations it detected. This was in the last 3 days, I believe. So yeah, it's just 3 days of data. And this is, pretty sure this is recent data, if I'm not mistaken. I don't know, let me know in the comments. Okay, so let's see what kind of data we actually got from this here. So we got a fires.txt. Alright, so this is what the fires.txt, this is what the data actually looks like in a text file. So that's one reason you might want to open an Excel file with all this data. But you can use Python to parse through this. I mean, as you can see, each section's separated by a tab. So we got latitude, longitude, and then some other data. And then as you can see, here's latitude, longitude. And let's open this in a Excel file. Let's see what the Excel file created here. This was all created using Python, so I didn't actually do any of this with by hand. All right, is it opening up? There we go. Okay, so here's our Excel file. As you can see, latitude, longitude. It's all nice and organized in here. But as you can see, it doesn't tell us where the location is. So what I did, I wrote a Visual Basic macro. And so to open this macro, first you want to go to Developer tab. Click on Visual Basic. That'll open this up. And then you're going to insert a module. And then I've got this Visual Basic macro code over here. Let me jump over to VS Code. Where's my macro code? There it is. Bam. So I got this. This is a Visual Basic. Basically, accesses openstreetmap.org. It takes the coordinates, converts it into a location. And this actually adds a function to or adds a formula to Excel that you can use. I'll show you in a second here. So I'll save this. And also you got to save your Excel file as a macro file. So you got to go up to Save As, Excel, SM, Save. All right. There's that. All right. So now we did that. We should be able to run this or actually it's up here. So what we're going to do now, we're going to go over to our, I don't know if you can see this here. Let me get some empty cells over here. Okay. So we're going to create a formula equals REV. Let me see, reverse geocoder. So you see I added this reverse geocoder formula. And let me see if I can tab there. Okay. And now we're going to take that's our first value and our second value. Go ahead and give it a parentheses. Oh, and user defined type not defined. Okay, what happened here? Oh, you know what I gotta do? I gotta come up here to tools. Oh, I gotta stop this for a second. All right, tools, references. Nope, may not be able to see us on your screen. Okay, so there's a bunch of references we can make to code. I need to come down to Microsoft XML3 version 3.0. And you click that little box, Microsoft XML version 3.0, I believe, to get this little snippet to run. And there's a lot of different code you can reference. I'm not going to go too deep into Visual Basic right now, so let's save this. Let's go back over here. Oh, and let's see if it will give us the value here. As you can see, enter. Oh, there we go. We got a value for it. Even though it's not in English, it's in some other language. Not sure what language that is. But that is the location of these latitude and longitude according to this reverse geocoder script. I'll jump over to VS Code. Basically, this is pulling up openstreetmap.org, and then it's getting latitude and longitude and returning a value based on whatever it finds at that URL. This is another API, free to use. So I'll leave this link in the description to all this stuff. Link to GitHub, all that good stuff. So yeah, there you have it. I think we pretty much figured it out. And now if you want to find a specific section of wherever you're out in the world, what you do is you go to your graph here, and you can say, okay, so you want to find North America. Well, that's between, let's say, -150 longitude and -50 longitude. So you can sort that. You can go into your Excel data, sort everything that's between those 2 points on your longitude, and then say your latitude is let's say 0 to, let's say, 60. Then you can just sort it, based on that, find all your data for the area that you're in. And let me know in the comments if there's better ways to sort out this data, figure out where the latitude and longitude are. I mean, 'cause that's really all it gives you. Go back to the Excel data here. So I mean, basically, this is the satellite fire or wildfire satellite data from NASA, free to the public. So check it out. If you like this, go and subscribe and leave a comment below.